I've got a very simple question for you. Does it matter whether I send this $100 to my grandmother or I send it to the most notorious criminals in my city? Actually, this is the question you are going to face when you will be dealing with fraud detection. And it's a difficult question because the fraudsters, what they will do, they will try to mimic real-world behavior. That's why this $100 you're about to send to your grandmother will have exactly the same properties as $100 someone will try to send to Don Corleone. The same goes for electronic transactions. From the bank's point of view, they will be just two independent rows in the transactions dataset. Here's the thing, in fraud detection, context is everything, and your connections help to discover a lot of information about your real context and your real behavior. In this video, I will show you how graph neural network can help you to discover those patterns and how this $100 may not be as innocent as it seems. Imagine you discover that a middle-aged woman calls a middle-aged man from times to times. It seems innocent, right? And the same man helps to run a local business to another young man. Still looks pretty innocent. But then you discover that the same man is connected to Walter White and Gustavo Fring, who are the most notorious criminals of the city, and the last two don't go well with each other. In this moment, you start to realize that this network is not that obvious and there might be some connections that you are not aware of because of the context. And it actually comes true. You discover a lot of episodes where those guys are connected with each other. So, as I said, your context defines who you are. You can't fake it and you can't ignore it if you want to build robust fraud detection systems. So, for the purpose of this video, I will be using elliptic Bitcoin transaction dataset that is available on Kaggle. I will put the link in the description. It is actually a synthetic dataset, which means it does not have the true values. But the reason I chose it is that this synthetic data was generated using the real data, so it mimics the real world behavior. As in real life, your data will contain known bad transactions, known not bad transactions, and a huge number of transactions whose status is unknown. Usually, people will put those unknown transactions into the group of known not bads. But actually, it's a very strong assumption that you have to check and you have to think carefully before taking this decision. In our case, around half of the transactions are known illicit transactions, around 20% are known licit transactions, and the remaining 30% are unknown status transactions. In real life, every client and every transaction will be represented by a list of features characterizing it. Think about it, some client age, amount of the transaction, total client turnover, country that the client belongs to, etc., etc. In our case, since we're operating with the synthetic data, this data will not be meaningful for us, but they will have a similar distribution. Think about it as if someone who wanted to make this dataset anonymous ran a PCA algorithm on these features, and the features that you see in this dataset represent results of this PCA transformation. So, as I said, our goal here is to build a model that will be able to learn from these features and the connections between different elements in the dataset and help us to predict illicit transactions. And before we jump into details, let's talk about why graph neural networks is the go-to choice when you work on this type of projects. In a classical machine learning approach, we would take each transaction as an independent observation, build a feature vector for each transaction, and we will hope that a machine learning algorithm will be able to find those patterns that distinguish licit transactions from illicits. But in the transaction world, no one is isolated. So the fact that my context depends on the context of people that I'm connected to really helps graph neural networks to find and discover much more complex patterns to discover fraudulent activity. Think about it as in convolutional neural networks, when the value of a point does not only depend on the value itself, but also depends on the value of the points surrounding it. Graph convolution layer will work exactly the same. So at the first layer, it will allow the node not only access its own context, but also allow to get the context from its direct neighbors. As we add more layers, we add possibility for the GCN not only to learn from local context, but also to learn from the global context surrounding each node. If you want to understand more about how graph convolutions work, I highly recommend this article on TensorFlow. TensorFlow and PyTorch have packages that help you to deal with graph neural networks. And if we were to build a system for production, my personal choice would be TensorFlow. But for the sake of this tutorial, I will be using PyTorch because it's a bit easier to set up, a bit easier to train, and a bit easier to explain how it's working. So in this video, we've explored the business problem, identifying fraudulent transactions, understood the data, the Bitcoin elliptic dataset, and understood the method that we're going to use, the graph convolutional neural networks. In the next video, we will build a minimal viable product of a graph convolutional neural network and build a model that is capable of predicting, depending on the context, how innocent the $100 that you are about to send are in the banking world. So, what do you think about graph neural networks? Would you like to try them? Are you excited about them? Let me know in the comments. Please like, subscribe, and hit the bell button so that you don't miss the next video when it gets published.